In this fourth video, dedicated to the Gilbreath principle and calculating surprisals for such performances, I give one that includes all of the previous videos as a special case. I do this by introducing a parameter L that represents the cycle length of the cyclic structure. So here within this activity, you will be able to change on the fly the cycle length to match the Gilbreath routine you're hoping to perform. So let's go ahead and start at the beginning. Given a standard deck of 52 cards, we will analyze packets of size n times L that consists of n cards from L categories of interest, with the proviso that n times L is less than or equal to 52. To facilitate graphing in Desmos, the variable x will be used in place of n. In other words, the functional variable x that we will use represents the number of cards from each of the L categories of interest. Once again, provided that L times x is less than or equal to 52. This means that the packet size for each given value of x is L times x. Specific cycle lengths L are selected by using the slider provided, which enables different packet structures to be analyzed. Since we are modeling possible scenarios for a deck of 52 cards, the permissible values of x are positive integers between 2 and 52 divided by L. Therefore, when interpreting the various graphs, we need to mentally multiply the value of each x-coordinate by L to obtain the actual size of the packet of cards being represented. Although each of the following functions only makes sense for discrete values of x, namely positive integers, Desmos uses a generalized factorial function, the gamma function, to draw a continuous graph that connects the corresponding discrete points in the plane. So as mentioned, here is our slider that will change the cycle length of the packets that we're working with. And as you can tell, it will change the Surprisal value for the corresponding packet that has that cycle length. Surprisal analysis. So here are the Surprisal functions. So let's take a moment and look at how these were constructed. And you'll see that the formulas involved are direct generalizations of the expressions that we found within the first 3 videos dedicated to the Gilbreath principle in finding Surprisal values for such performances. So we're looking at cycle structures having cycle length L, where there are x cards from each of the L categories of interest. And L falls between 2 and 26 inclusive, and x is any positive integer between 2 and 52 divided by L. We'll denote any packet of cards satisfying the above as a C packet, C standing for category. The total number of C packets is therefore the following expression. And as already mentioned, you can see that this is simply a generalization of the previous expressions that we have worked with within our videos focused on the Gilbreath principle in this series. And as was the case in previous videos, this expression here can be derived using the fundamental counting principle, also called the multiplication principle. Now, the total number of permutations of these L times X cards will, of course, be the quantity Lx factorial. So given these two expressions here, we can now find the probability that a packet of L times X cards, in which there are X cards from each of the L categories, is randomly mixed and then found to have a perfectly cyclic structure relative to these L categories. Okay, so that's what we'll find next. The probability that that would happen by chance alone. So given the above LX cards, the probability that a random mixing of these cards would yield a C packet is the following. It's the number of, quote, C packets divided by the total number of permutations of those LX cards. Once we have the probability, we're just one step away from finding the surprisal. The surprisal of such a packet occurring by chance alone is the following. It's log base 2 of 1 over the probability of obtaining this structure for the packet by chance alone, which is equal to log base 2 of this expression here reciprocated, which is what we've listed down here. Okay, so let's go ahead and take a look at an example using this more generalized Desmos activity. Now, what I've chosen to do is work with, so focus up here, if you can see the mouse moving, I'm going to move the cycle length over to 6. So over to 6, cycle length 6. Now, unfortunately, it goes off the chart a little bit. So let me just make an adjustment here. Okay, so that's a bit better for the packet structure that I have created for the cards that are before you on the right-hand side of the screen. Now, for those who have watched very many videos on the Hidden Structures channel, you'll know that once you have a cyclic packet, it's invariant or unharmed by packet cuts. You can cut it as many times as you like. Something that's far more powerful is something called the Charlier shuffle. And I have a separate video that teaches you the Charlier shuffle. This is a very, very convincing shuffle in which all of the action that you're witnessing right now is equivalent to just cutting the cards at some location. Okay? So the Charlier shuffle is equivalent to just cutting the cards. Well, cutting the cards will not harm a cyclic organization of a packet of cards. Okay, that's the key. But it sure looks like the cards are being mixed, scrambled, and even randomized in the mind of the spectator watching that. Okay, so it's a good thing to be aware of, that once it's cyclic, you can perform that shuffle among others as well, but that one is a gem of a shuffle for cyclic packets. Okay, so if you've watched the most recent videos, you'll probably know what we'll do next. We're going to now Gilbreath shuffle this packet of cards. And what does that consist of? Well, recall that consists of reverse counting, or in other words, dealing to the table any number of cards. This can be dictated by the spectator. They can tell you when to stop dealing. Okay, that's the first step in any Gilbreath performance where cards are dealt to the table. And then the second step is to perform a riffle shuffle. Well, to perform a riffle shuffle, given such a relatively small packet of cards, is a bit tricky. So a better shuffle to use in this situation, when you have a smaller packet to work with, is to use a rosette shuffle. This is where you just spin the cards and then you just bring those two halves together, and now they're interlacing however they may. We have no idea. No one's controlling that, as you can probably tell. No one's controlling how those are being interlaced. Okay? And that is indeed the case. I have no idea how these were interlaced. Okay? So we reverse counted a number of cards, and then we performed something that's equivalent to a riffle shuffle, Well, the Gilbreath principle is now in force, okay? And so what the Gilbreath principle will say, in my case, we chose a cycle length of 6 right here, okay? So that means if I go ahead and just push off 6 cards there, and then push off 6 cards here, and then 6 here, and I believe I should have 6 here. There you go. We have 4 sets of 6 cards each, okay? Now, I haven't told you the exact structure here, so I could have this written on a piece of paper that I would open up and now state what's going to happen, or I could have predicted ahead of time what would happen and actually clearly state it, okay? So let me tell you what my prediction was. And it could have been written on a piece of paper, like I said, so you can open it up and say, after the random dealing of any number of cards to the table decided by you, the spectator, and then after a messy either riffle shuffle or rosette shuffle, groups of cards were pushed off from the top of the packet into 4 piles, and amazingly, each of these 4 piles is the answer to one of the greatest questions in all of human history. What is the answer to life, the universe, and everything? And then there's a hint down here. Hint, add up the card values to obtain the answer. Okay, let's check this here. What's going on here? Okay, so the claim is, let's take a look at these. Let's see, so we add the card values. Well, see, a jack's 11, so that's important to realize. 3 plus 11 is 14, plus 5 is 19, plus 6 is 25, plus 8 is 33, plus 9 is 42. The cards add up to 42. And if you were now to go to Google and type in the query, what is the answer to life, the universe, and everything, it will give you the answer of 42, okay? Now, of course, this could have just been outrageous luck here that it happened. Really, there's no way that all of these add up to 42, right? I mean, what are the chances of that, given the randomization of the cards? 8 plus 4 is 14, plus 9 is 23, plus 5 is 28, plus jack is 39, plus 3 is 42. That one adds up. Can you even imagine the probability of this happening by chance alone? 16, 19, 28, 34, 42. Ha! The pattern's got to break now, for sure. 8, then 14, 23, 28, 39, 42. Each set of 6 cards adds up to 42. How did we accomplish that working together? Because we did work together. You decided how many cards to deal to the table, and then you decided how those were riffle shuffled or rosette shuffled together. In fact, in some ways, it was the universe deciding how those were interlaced. You saw how messy that was. But despite all of those random choices and unknown processes for the interlacing of these cards, each set of 4 provided the answer to life, the universe, and everything. Whoa! Okay, so that is a performance using our generalized Desmos activity, where you can choose any cycle length that you would like to work with, okay? So you can get cycle length of 2, 3, 4, all the way up to 26 for a standard deck of cards. And of course, you could have higher cycle lengths if you're willing to work with more than one deck at a time. So let's go ahead and find out what is the surprisal associated with the performance that you've just watched. What level of surprise is the spectator likely to experience in seeing the successful completion of this routine? Okay, well, let's go down here and take a look. So we're looking at the Surprisal functions. Now, of course, the original organization of the cards, quote, has a higher Surprisal level because it's more structured, right? But to set that up ahead of time should not be surprising to anyone, that it can be set up to cycle through certain values. Okay, that's not the surprising part. The surprising part is when we Gilbreath shuffle the packet and then in the end are able to reveal something that is extremely unlikely. Okay, so that's what we're doing. We're focused on the Surprisal value for the Gilbreath shuffled version of our quote C packet. So it's the middle column right here. Okay, so what we need to do is we have to go down and find the value of X that was used in this performance. Well, just think about it. L is 6. The cycle length is 6. How many sets of 6 cards were set out? How many sets of 6 did I have? I had 4 of them. So I had 4 times 6, a total of 24 cards in the original packet. So if we come over here, we can see what the Surprisal value is for this Gilbreath performance that we've just completed. It's 13.56 bits of Surprisal. So we'll round it down to 13. That's fine. Do you remember the interpretation of Surprisal values in the context of ordinary coin tosses? So 13 bits of Surprisal is measuring the degree of surprise one would experience and watching 13 fair coins tossed into the air with somebody predicting before the coins hit the table that all 13 coins will land heads up. And after they land on the table and settle down, it is indeed found that each of the 13 coins is heads up. And it was predicted before the event occurred. So the level or degree of surprise associated with witnessing that random event is a little bit less, actually, than the degree of surprise one would experience in watching this Gilbreath performance today. Okay, so that gives you a feel for how unlikely and surprising that would be. So I will provide this Desmos activity in the description below so that you can use it and change the values of L for the cycle length, and then you can apply it to any Gilbreath performance that we've looked at so far and countless others that you can actually now design. Okay? So this activity here could be used to find Surprisal values for cyclic packets with cycle length 2 that we've already covered, for cycle length 4, which we also covered, and then we also did a little video on cycle length 13. Well, we can find all of those values within this one activity. So this is a powerful little Desmos activity to keep safe for future reference. In the next video dedicated to finding Surprisal values for Gilbreath performances, we're going to be working with perhaps the most famous deck structure of all time. It's called Cy Stebbins. So a Cy Stebbins deck is one that has interwoven cycles of length 2, 4, 13, and technically even 26. Because really what we have done so far is work with cyclic structures that are cyclic relative to only one cycle length. We haven't dealt with ones that are nested or interwoven. Okay, so that's what we'll do next time. And when Gilbreath shuffling such a deck, the Surprisal value and having all of those characteristics at once is off the charts. And that simply results from Gilbreath shuffling the Cy-Stebbins deck that is used in many applications in mathematical card magic. So thank you for watching.